Good evening, and welcome to the Sleeping Zoo. Facts to fall asleep to. We move now to the open skies of the North American continent, focusing our attention on an aerial marvel whose existence is defined by one of the most astonishing feats of endurance in the natural world. The monarch butterfly, Danaus plexippus. This creature, known for its brilliant orange and black livery, is not just a delicate insect. It is an epochal navigator, a fragile powerhouse whose annual, multi-generational migration defines the very connection between distant continents and symbolizes the vulnerability of global ecological networks. To truly appreciate the monarch is to understand a life lived entirely on the wing, a cycle of transformation and transcontinental travel that begins with a unique and specialized physiology which sets it dramatically apart from its myriad cousins in the order Lepidoptera. To begin, we must situate the monarch within the broader context of general butterfly biology. The order Lepidoptera, comprising butterflies and moths, is characterized by the presence of scales covering the wings, from which the order derives its name meaning scale wings. For the vast majority of the approximately 18,000 butterfly species worldwide, the physical structure is optimized for localized flight, short dispersal, and immediate reproduction. A typical temperate butterfly, such as a red admiral or a sulfur butterfly, possesses wings that facilitate erratic, fluttering movement, often favoring bursts of speed to evade immediate predation, but generally lacking the aerodynamic specialization for sustained, long-distance travel. Their primary function is to locate suitable host plants for their eggs and to find nectar within a limited territory, rarely venturing more than a few kilometers from their natal location. Their life is often a rapid dash, defined by the necessity to complete a single breeding cycle before the changing seasons intervene. The monarch, however, represents an evolutionary extreme, possessing a physical structure optimized for high-endurance, long-haul flight. Its wings, spanning between 9 and 11 centimeters, are covered in thousands of tiny, overlapping scales made of chitin. This structure not only gives them their vibrant color, a classic example of aposematic coloration, warning of toxicity, but also crucially aids in passive heating by efficiently absorbing solar radiation, a necessary mechanism for gaining the thermal energy required for flight, particularly at higher altitudes or early in the morning during migration. Their distinctive pattern, a rich orange-red set against thick black veins and a white spotted black border, is a vital piece of visual communication, signaling to predators, particularly birds, that the butterfly is noxious and dangerous to consume. Contrasting sharply with most non-migratory species, the monarch's body, or thorax, is densely packed with exceptionally powerful and efficient flight muscles. While most butterflies engage in highly erratic and energy-intensive flapping, the monarch is a master of gliding and soaring, utilizing thermal air currents to conserve energy and maximize distance traveled per unit of energy consumed. This allows it to sustain flight for hours, driven by a metabolism that can utilize stored fats and carbohydrates with remarkable efficiency, a stark biological difference from the short-lived, low-endurance flights of its sedentary relatives. Furthermore, most butterflies rely on simple visual cues to navigate local habitats, recognizing familiar landmarks and color patterns associated with nectar and host plants. The monarch in sharp contrast, possesses a highly advanced internal clock and magnetic compass system. Scientists have determined that the monarch's antennae contain photoreceptors that detect the position of the sun. The butterfly's internal clock then integrates this positional information with the time of day, allowing it to maintain a precise southward bearing across thousands of kilometers, even as the sun moves across the sky. A phenomenon known as time-compensated sun compass navigation. Additionally, there is strong evidence suggesting the monarch can sense the Earth's geomagnetic field as a backup or supplementary navigational tool, a level of inherited intercontinental navigation that is almost entirely absent in the non-migratory majority of Lepidoptera. This sophisticated physiology is inextricably linked to the monarch's unique system of chemical defense. To fully appreciate its effectiveness, we must first consider the general range of defensive strategies employed by other butterflies. Most non-toxic butterflies rely on two primary methods: cryptic camouflage, where the butterfly mimics leaves, bark, or thorns to hide from predators, or flash coloration, where a hidden bright pattern is suddenly displayed to startle an attacker, giving the butterfly a moment to escape. A more advanced strategy common in Lepidoptera is Batesian mimicry. In this scenario, a palatable species evolves to look visually identical to a truly toxic or unpalatable species, effectively cheating the predator by borrowing the warning colors. The viceroy butterfly, for instance, has long been a classic example of a Batesian mimic, closely resembling the monarch to avoid predation, capitalizing on the monarch's earned reputation for toxicity. The monarch, however, is not a mimic. It is the model in a system known as Mullerian mimicry. It is genuinely toxic, and its coloration advertises this fact honestly. This toxicity is not manufactured internally, but is acquired during the larval stage. The caterpillar possesses specialized, complex mouthparts and digestive enzymes that allow it to consume the leaves of the milkweed plant, Asclepias species, without being poisoned. Milkweed contains highly toxic compounds called cardinolides, a type of cardiac glycoside that interferes with heart function in most vertebrates. The monarch caterpillar sequesters these toxins in specialized tissues, carrying them through metamorphosis into the adult butterfly. This process, known as sequestration of secondary metabolites, renders the entire insect highly unpalatable and often lethal to most vertebrate predators, acting as a crucial chemical defense mechanism that is entirely dependent on its single host plant. This reliance on a single toxic host plant for its chemical defense is a key differentiator from most other butterflies, which are generalist feeders or utilize non-toxic defenses. The behavior of the monarch is dominated by two radically different modes of existence: the breeding generation and the migratory generation, each with its own specialized genetically coded agenda. The typical life cycle of a butterfly is multivoltine, completing several short-lived breeding cycles within a single growing season, with the final generation entering a period of hibernation or overwintering as a pupa or egg in the local region, simply waiting for spring. The monarch, in contrast, utilizes a multi-generational relay for its migration, a behavioral anomaly unique in the scale of the Lepidoptera order. The life cycle itself is a continuous chain of metamorphosis. The first 3 generations of butterflies born during the spring and summer are the breeding generations. They are programmed for immediate reproduction. They live for only about 2 to 6 weeks, dedicating their short lives entirely to mating and laying eggs, pushing the population progressively northward from the southern breeding grounds. These individuals are the biological engine, moving the species gene pool forward on the continent in a rapid, self-sacrificing succession. However, the final generation of the year, usually the fourth, born in late summer, exhibits a completely different, genetically triggered behavior. The supergeneration, or Methuselah generation, triggered by shortening daylight, hours, and cooling temperatures, these butterflies enter a state of reproductive diapause, meaning their reproductive organs remain immature and undeveloped. This metabolic slowdown extends their lifespan drastically from 2 weeks to 6 to 8 months. Instead of breeding, they dedicate their entire extended lives to a singular monumental task: the transcontinental migration. These are the great navigators, flying over 4,000 kilometers from Canada and the northern U.S. to small, specific overwintering sites in the Oyamel fir forests of central Mexico, a journey that no single butterfly has ever completed before, and which their grandparents began. This inherited, innate knowledge of a geographically precise, distant location, passed down through several short-lived generations, is perhaps the greatest mystery of their behavior and the most striking contrast to the sedentary existence of most other butterflies. The habitat and ecology of the monarch butterfly spans the length of the North American continent and is entirely dependent on the presence of 2 distinct and widely separated environments, a level of bicontinental resource reliance that is exceptional among butterflies. The majority of butterfly species are local specialists or generalists, requiring only a host plant and nectar source within a few kilometers. The monarch, for its breeding habitat, requires the continuous presence of milkweed, its sole host plant, which historically thrived in meadows, roadsides, agricultural margins, and prairies across the entire eastern half of the U.S. and Canada. The western population of monarchs, though smaller, relies on milkweed west of the Rocky Mountains and overwinters in groves of eucalyptus and Monterey pine along the coast of California. The overwintering habitat in Mexico, however, is extraordinarily specific and geographically restricted, confined to just 12 sites, most concentrated within the Monarch Butterfly Biosphere Reserve in the Trans-Mexican Volcanic Belt. This is the crucial bottleneck for the entire eastern North American population. The Oyamel forests provide a unique, necessary microclimate. The dense canopy of the Oyamel trees acts like a blanket, insulating the clusters of millions of butterflies and maintaining a cool, humid environment. This microclimate prevents the butterflies from freezing during cold snaps and conserves the fat reserves they need to survive the winter and begin the journey north in the spring. If the environment becomes too warm, they use up their fat too quickly. If it becomes too cold, they freeze. This narrow thermal and humidity buffer makes the Oyamel forests irreplaceable, making the entire species' existence dependent on the preservation of a few dozen hectares of forest in a single mountain range. The monarch's ecological role is dual and vital. In the larval stage, it acts as a primary herbivore of the milkweed plant, playing a role in population control of the host species. In the adult stage, it is a significant pollinator, traveling vast distances and aiding in the reproduction of numerous flowering plants, including many wildflowers and crops, contributing to the broader biodiversity of the North American ecosystem. The entire ecosystem, from the prairies of Canada to the mountains of Mexico, functions as an interconnected system of resources, with the monarch acting as the biological thread that ties them all together, a degree of ecological linkage far exceeding that of a typical local butterfly. The complexity of this continental dependence leads directly to a serious examination of the monarch's conservation status and threats. The sheer scale of its migration, which was once a spectacle of billions of butterflies darkening the sky, has diminished dramatically in recent decades, leading the UCN to list the migratory monarch as endangered in 2022. The threats are global and systemic, attacking the butterfly at every stage of its life cycle and across all three nations involved in its migration. Firstly, loss of breeding habitat is the most pervasive problem. The widespread adoption of genetically modified, herbicide-tolerant crops across the U.S. Midwest has led to a catastrophic decline in the availability of milkweed. Farmers can now spray broad-spectrum herbicides that eliminate every plant except the crop, systematically wiping out milkweed, which once thrived in farm fields and margins. Since milkweed is the obligate host plant for monarch larvae, its elimination directly starves the breeding population that feeds the southward migration. This direct, herbicide-driven habitat loss is a primary driver of the decline, a specific threat not faced by the majority of butterflies, which can often utilize a variety of host plants. Secondly, loss of overwintering habitat is a critical, localized threat. Despite the protected status of the Mexican forests, illegal logging and encroachment by local communities seeking firewood or agricultural land continue to degrade the Oyamel fir canopy. As the protective tree cover thins, the microclimate is lost, exposing the dense butterfly clusters to lethal freezing temperatures or accelerated energy expenditure, leading to massive mortality events in vulnerable years. This vulnerability, concentrated into a tiny geographical area, is unique to the migratory monarch. Thirdly, climate change introduces volatility across the entire range. Extreme weather events, such as unseasonal freezes in the south or prolonged droughts in the breeding range, can decimate large portions of the population. Furthermore, altered temperature regimes can disrupt the delicate timing of the migration and the synchronization between the monarch's arrival and the availability of milkweed in the north, leading to a biological mismatch known as phenological mismatch that severely reduces reproductive success. Conservation efforts are now intensely collaborative and focused on habitat restoration across all three nations. Massive, transnational campaigns are underway to encourage citizens to plant native milkweed species in gardens, schoolyards, and along utility rights-of-way, effectively creating monarch way stations to support the breeding generation. Furthermore, efforts in Mexico focus on sustainable forestry practices and providing alternative economic opportunities to the local Oyamel forest communities to reduce the incentive for illegal logging, framing conservation as an economic benefit through ecotourism. The challenge is immense, requiring sustained effort across national borders to repair the broken links in this great natural chain, a level of international effort rarely seen for non-flagship insect species. Considering its visibility and the awe inspired by its cyclical journey, The monarch features prominently in folklore and indigenous legend, particularly in Mexico, where its arrival coincides with one of the most significant cultural events of the year. While most butterflies are seen as ephemeral, fleeting creatures of beauty, the monarch's timely arrival gives it a spiritual weight. The traditional inhabitants of the region, including the Purepecha people, have long observed the mass arrival of the monarchs in late October and early November. In one of the most poignant legends, the monarchs are believed to embody the souls of the departed. Their arrival in the Oyamel forests perfectly aligns with the timing of Dia de Muertos, the Day of the Dead celebration. This association suggests that the butterflies are the returning spirits of ancestors, visiting their families during this sacred time. The bright color and the silent, fluttering masses settling on the trees provided a beautiful, naturalistic explanation for the phenomenon of spiritual return, giving the migration a profound cultural and religious significance that elevates the insect far beyond its biological reality. This legend provides an inherent conservation value, as the traditional communities view the butterflies with reverence and a protective sense of duty, a level of reverence far surpassing the casual appreciation given to most other local insect life. In the north, the monarch's journey has inspired stories of courage and transformation, reflecting the astonishing distance covered by such a fragile creature. Its metamorphosis from a caterpillar into a butterfly serves as a universal symbol of spiritual rebirth, change, and the potential for a glorious second life, themes that are amplified by the impossible scale of its journey. In popular culture, the monarch is less a character and more a powerful symbol, used to represent environmental fragility, natural beauty, and the wonder of nature's intricate systems. Its striking appearance and the almost unbelievable nature of its migration make it a favorite subject for photography, art, and literature, serving as a biological icon whose status far eclipses any other butterfly species in North America. The monarch's use in popular culture is often tied directly to environmental awareness campaigns. Its endangered status has elevated it to the status of a flagship species, much like the polar bear or the panda, where its image is used to mobilize public support and funding for habitat preservation. When people see the monarch, they are instantly reminded of the interconnectedness of nature and the devastating consequences of human action on fragile ecological processes, making it a perfect symbol for the conservation movement across the continent. This is a role reserved for only a handful of globally recognizable species. Furthermore, the migration itself has inspired artistic and literary representations, focusing on themes of navigation, inherited memory, and epic journeys. Films, documentaries, and even musical compositions have been created to capture the scale and silent determination of the River of Orange as it flows southward. The concept of a creature making a journey that none of its ancestors completed, yet following a path imprinted in its very DNA, resonates deeply with human themes of destiny, lineage, and innate knowledge, lending the butterfly a mystical, almost mythical quality in the modern imagination. The monarch butterfly, therefore, is far more than a beautiful insect. It is a living map of North America, a delicate testament to biological engineering, and a profound cultural symbol. Its very existence ties together the plains of Canada and the mountain peaks of Mexico in an annual pilgrimage of life and death, sun and shadow. The monarch's struggle for survival is a direct reflection of our own struggle to maintain the health and connectivity of the natural world. Its silent flight serves as a constant, fluttering reminder that the most amazing and enduring processes in nature are often the most fragile, requiring careful stewardship to ensure that this tiny orange engine of endurance continues its epochal journey for generations to come. The conservation of the monarch is, in essence, the conservation of an entire continental ecosystem. Thank you and good night.